Alright, let's look at the ODE practice problem number 6. Alright, so we want to find the power series solution of this given differential equation. Alright, let's see. First thing I would do is I'm going to put everyone on the left hand side. So I'm going to just subtract the 2y from both sides. So we have a y prime minus 2y is equal to 0. Alright, then so we have a power series for the solution, and the derivative. So if you take the derivative, y prime of x would be summation n goes from 0 to infinity, and the cn is there. Derivative would be n x to the n minus 1. And if you want, actually, since when n equals 0, the term is going to be 0 because n is right here. So we can actually start from 1, right? But if you really want to start from 0, we can do the following. So we can actually do a summation. N starts from 0. So instead of starting from 1, you're starting from 0. So we can just increase the index by 1. So you have n plus 1, and you have a c n plus 1, then you have x to the n, and to infinity. Alright, so we have the y prime and y, so we just plug it in. And so this is going to be, right, so y prime we just found, so it's a summation. N goes from 0 to infinity. Right, so you have n plus 1 times c n plus 1 and x to the n minus, x to the n, right, minus summation n goes from 0 to infinity, and 2 times, so I'm going to put, let's see, I'm going to actually put 2 inside. Alright, 2 times cn x to the n, right? And the right hand side is 0, so I just put 0 there. Alright, so since we have something in common, you can see that both have a summation here. It is actually exactly the same summation. And also, there's a x to the n, and here's x to the n. So I'm going to pull those out. So I'm going to write summation once. Summation n goes from 0 to infinity. And I'm going to pull x to the n out. And what's left is, let's see, so if you pull x to the n out, from the first summation you have n plus 1 times cn plus 1. And from the second summation you have a negative 2cn. Right, so this has to be equal to 0. Right, so in order to get a 0 on the right hand side, so we have to make sure that each coefficient, so this guy has to be equal to 0. Right, so what you get is this. Right, so you have n plus 1 times cn plus 1 minus 2cn must be 0. Right, let's solve for cn. Right, and add 2cn to both sides. You get n plus 1 times cn plus 1 is equal to 2 times cn. And then I'm going to divide through by n plus 1. So you have a cn plus 1 is equal to, right, you have a 2 over n plus 1 times cn. Alright, so we have a recursive formula for cn. So let's try to see if we can find it. Alright, so let's start with, let's start with n equals 0. Right, then you get this. Right, c1 is equal to 2 over 1 C0. All right, so when n equals 1, then you get the C2 is equal to 2 over 2 times C1, right? But the C1 is just the one before, so you get 2 over 2 times 2 over 1 C0, right? Then when n equals 2, and it's a little tedious, but we'll do a few of them so that we can see the pattern. So it's going to be 2 over 3 C2. Right, but the C2 is the one before, so you get 2 over 3 times 2 over 2 times 2 over 1 C0. All right, we're beginning to see the pattern. Maybe we should write it this way. So this one, it's a 2 squared over 2 times 1 is 2 factorial C0. And this guy, 2 cubed over 3 times 2 times 1 is 3 factorial C0. All right, so we're beginning to see the pattern here. So this you can think of 2 to the first power. 1 factorial is still 1, so we can put a factorial if you want. All right, now we definitely see a pattern here. So then you have dot, dot, dot. All right, let's try to find the Cn. All right, so it looks like a 3, n indicates the power, and the factorial on the bottom. So we have 2 to the, n over n factorial C0. All right, so we have a power series, so we know that the y of x, so therefore y of x is equal to summation n goes from 0 to infinity. All right, so Cn, we found out that the 2 to the n over n factorial C0 and times x to the n. All right, and we can actually, I'm going to pull this C0. This is just a number, so I'm going to place it in front. So we're going to get the C0 times summation n goes from 0 to infinity. All right, so I'm going to combine 2 to the n and x to the n. You can write it as a 2x to the n over n factorial. All right, and we actually recognize this guy. This guy is, you can see that this is the power series for exponential function, right? So this is going to be, C0 e to the 2x. Right? So this is the power series solution, but you can actually find a function corresponding to that power series. All right, that's it. I hope that this was clear.